Hello, and we are the Chef Min Group will present you about the centrifugal pump design. In Chef Min Group, there are 4 business partners that associate with it, which is me, Hidayat, Vira, Chan, and Aiman. And before that, I want to clarify, all the content in this video are not our own, but the trustworthy resources that we took from the internet. So, part 1 is the basic concept of centrifugal pump and self-priming pump.
Let's talk about centrifugal pumps, which is 85% of most water pump designs. The centrifugal pump uses centrifugal force to generate pressure and flow by pulling water into the eye of the impeller and then by spinning the water, forcing it to the outer edge of the impeller. The amount of flow and pressure is only limited by the size of the impeller, material strength, and speed of rotation. This device can be used as a single or multiple stage pump. Each stage has its own impeller. When used in series, large amounts of pressure can be generated at required flow rate. Pumps can be hooked in series or parallel to either increase flow or pressure. If hooked in series, the case pressure capability must be noted to ensure that the sum of the pressure that the 2 pumps can generate will not exceed the case pressure capability. Centrifugal pumps come in all sorts of configurations. This illustration only shows some of the designs that can use the centrifugal pump approach. Other designs include jet pumps, sump pumps, sewage pumps, and utility pumps, to name a few. These pumps can be applied to transferring water, supplying irrigation, supplying water to equipment, a business or a home, just to name a few. The pumps can be powered by electric motors, gas or diesel engines, power takeoffs of a tractor. Any rotary force can be used to spin an impeller to move water. Some impellers are attached to the power source direct or in a line shaft turbine remotely located from the pump with a long rotary shaft. The 2 working parts of the standard centrifugal pump are the impeller and the volute. The impeller imparts kinetic energy to the liquid being pumped, creating what we call pressure and flow. The volute gives direction and control to the motion of the liquid being pumped. The pump works by the pump case being filled with water, which is called priming. When the impeller turns and forces the water to the outside circumference, the water is moved toward the discharge of the pump. As the water moves to the discharge, a vacuum is formed at the eye of the impeller, causing more water to move into the impeller. The vacuum that is formed at the eye of the impeller created a pressure differential with the outside atmospheric pressure. With the atmospheric pressure being greater than the vacuum inside the pump, the outside pressure pushes a continual flow of liquid into the pump. As we move up in altitude, the atmospheric pressure is reduced and the force pushing the water into the eye of the impeller is also reduced, diminishing the performance of the pump. When talking about centrifugal pumps, we need to talk about priming or losing prime on a pump. Centrifugal pumps do not work if the eye of the impeller pulls air in, which is called losing prime. If this occurs, the pump will not create the needed vacuum or pressure. Just like someone sucking on a soda straw, if you take your lips away from the straw, the fluid falls back into the container. What makes the difference between a straight-in suction and a self-priming pump is the location of the suction opening. On the self-priming, you will note that the suction and discharge are both above the impeller eye, plus some additional baffling in the body of the pump. Please note that self-priming is a misnomer in most cases and probably should be referred to as a prime-at-once pump. If a pump is pumping from a positive suction or flooded suction, then you have a booster pump. If the pump is lifting water from below, then this is called a negative suction lift. With negative suction lift, there is a practical limit at sea level of 25 feet. Some pumps by design cannot lift water with a 25-foot suction lift due to design. Be sure to know the limitations of the pump in question for your application. This limit is the sum total of the elevation change, friction loss, and altitude of the location. These limitations are based on atmospheric pressure and the properties of the fluid being pumped, which in this case is water. As we go up in altitude, the ability to lift water from the source decreases. While this was a limited presentation of centrifugal pumps in general,
this is a self-priming centrifugal pump. It's called TPS. So it's based on our regular centrifugal pump TP on that series, but has some self-priming capabilities. It means that, in fact, it can evacuate pipelines. So it is used wherever some gas has to be transported through the pump. So actually, when we have an empty pipeline, the pump can suck the gas through the pump and then start pumping a product, for example. Compared to other self-priming pumps, our pump handles the product or the liquid it pumps very gently.
The GEA tangential self-priming pump of the TPS series are used for conveying aggressive cleaning liquids that are free of abrasive constituent. Pumps of the TP series are horizontal self-priming pumps. They stand out by their sturdy construction.